Hello. In this video, we'll be using the PaLM 2 large language model and specifically various simulacra of that large language model to answer the age-old question of tabs versus spaces. We'll be hands-on and specifically showcase the use of the PaLM API and Vertex AI, as well as the Kubeflow Pipelines concepts. Whether or not you're using Vertex AI, Kubeflow, or PaLM, we hope that this video will nicely highlight how you can think about serverless pipeline productionalization of LLM APIs. With what we're trying to achieve now established, let's jump into the Google Cloud Console to see some related concepts. So, I'm going to go to the Vertex AI page and specifically the model garden. The model that we're going to be using is the PaLM API for text. If I go into the model and open that prompt design, we'll then be in the Generative AI Studio for language and be able to structure our question. Now, the idea is that we'll be creating simulacra of this large language model by providing a context here. So, for example, we could say, as a junior software engineer, answer the following questions. And then we can use this text box here to ask questions like, which is better, tabs or spaces? We have no interest in a nuanced, data-driven, or evidence-based answer, so let's force a much shorter answer with a low token limit. In this case, we're seeing that the junior software developer would choose tabs. Now we're going to productionalize this token generation and parallelize these machine learning API inferences by using Kubeflow and Vertex AI pipelines. So let's now open up an IDE to get started on that. All we need for Kubeflow Pipelines is a pipeline Python file, which will generate the YAML specification for a pipeline that we can run on Vertex AI. Now, we don't really want to start from scratch since the Google Cloud Console has a nice interface for getting some example Python code. So, for example, I can view started code here. I'm going to bring in this code in a slightly modified form and we'll talk through those changes. First, though, we want to run a couple imports to use the Kubeflow Pipelines library. And then we'll bring in our modified function. The required module imports are moved inside the Python function as is required by Kubeflow components. We also need to mark this as a valid Kubeflow component, so we'll add the associated decorator here. We need to import the Google Cloud AI Platform package to be able to use this Vertex AI module in the component. We're also shortening the Python code a bit by skipping the logic around using a tuned model. We're just going to use the out-of-the-box PaLM model. Lastly, we're simplifying the arguments of this prediction function. Overall, though, the code is quite similar to the example that Google provided. When we get that generative response, we're going to write it to a Kubeflow pipeline dataset, which can be used in subsequent pipeline components. After running those inference tasks, we'll want to count up the use of tabs versus spaces in the responses, and then calculate sums to get our final result. Let's provide a few constants at the top of our Python script here for the model that we're going to use: the temperature, which is effectively the randomness of the generative response, the token limit, which is not the context window, but rather the maximum number of tokens that we'll get in any response, and then some lower level parameters, top P and top K. These all match the standard configurations that we have in the UI here: temperature, token limit, top K, and top P. We got this prompt format from the Python code example, which has the context up front, and we've just parameterized that string. Next up, let's go ahead and create the pipeline itself. In this pipeline, we're going to use a parallel block for a wide variety of different software engineering roles, and then use that function from earlier, respond simulacrum, to get an answer for whether tabs or spaces are preferable. For each response, we're going to count the number of times that the word tabs showed up in the answer, as well as how often the word spaces showed up in the answer, and we're going to do that in a case-agnostic way. Once we have those counts, we'll have this task at the end here, which collects across that looped component to be able to get an aggregate result, seeing which was mentioned more, tabs, or spaces. Outside of the components of pipeline, we need a compilation command to create our YAML pipeline specification. All this code is shared in the description of this video for your reuse and experimentation. All right, let's go ahead and run this script now. If you don't have KFB installed, you can do that with pip. We're going to use the Kubeflow Pipelines version 2, which is technically not the stable major version, but we found it to be pretty stable in our own practice. After a successful run, we now have our pipeline.yaml file. Before we run this on Vertex AI pipelines, we'll just want to create a storage bucket. We'll go to the home page, then Cloud Storage, and we'll create a bucket here. All the defaults should now be fine. Now let's copy our pipeline demo file to that bucket. And there's our pipeline YAML. Let's go ahead and give this a run in Vertex AI pipelines. To create the run, import the specification from Cloud Storage. For the output directory, let's use that same ML tabs versus spaces bucket, and then we'll specify our project ID and ask the question that we want to ask. We're using "if you had to decide" as part of the prompt here, just so that we don't get any fuzzy, it depends sort of answers. We want extraordinarily strong opinions about this very important subject matter. All right, let's go ahead and submit. Now, if you get this error here, it just means that you haven't used Compute Engine before, and you do need to have that service enabled before running Vertex AI pipelines. Since this is a completely fresh project, we do need to enable that API, so we'll go to the Compute Engine page and enable the API. With that API enabled, let's go back to Vertex. The recommended APIs here may also be enough to be able to run the pipelines. Let's give it another go, and now we're getting a successful run. So we have our aggregation task here, and then a pretty large loop over our different software engineering roles in the middle. It looks like we have about 30 different roles that we're going to be using, and therefore we'll be asking this question to 30 different simulacra of the PaLM model. Let's go ahead and let it run here. It'll take a couple of minutes. Then we can start to see some of the results coming in, while some are still finishing up. For example, for our backend engineer, if we look at the response, we can download that artifact and then view it here in the IDE. Our backend engineer prefers tabs because they are easier to read and align code. It looks like all of our different roles have responses that are accounted for. So we'll just compile the results here and be able to settle this question once and for all. One particular thing to note is that we ran all these in parallel, which is about 30 API requests, a decent amount. So you may want to keep an eye on rate limits. It seems everything ran fine in our case, but this level of parallelization can sometimes be a bit much, depending on the type of APIs that we're hitting and the rate limiting policies. With the results completed, let's check the output, and we find that while there seems to be pretty good deviation, spaces are indeed better than tabs. So, through our Python code, which created a Kubeflow pipeline, we were able to create a pipeline definition and run that on Vertex AI to be able to answer the question across a wide variety of different software engineering roles, which is better, tabs or spaces. And now we know. We'll keep an eye on the comment section for any questions and want to thank you for watching.